Assalamu alaikum. Um, Given that this is my first ever stream, so I should probably introduce myself. My name is Adam and I'm currently doing my master's in computer science. Recently, I was searching for a good note-taking app and I came across this app called ROM Research, and most of you probably know about this app as it's quite trending nowadays. And after watching a few videos and going to their site and learning about their pricing model, which is I think quite hefty for size, this stream let me wait, my stream connection is very poor. I should switch up my network and hopefully this will fix the problem. Wait a second. Okay. I'll just see if my connection gets better or not. Still it's going poor. I forgot to use it. Is it somewhat better now, or it should be relatively better? Anyways, so can you guys hear me well? Or is there some lag? Let me know if there are any problems. Okay, so what were we talking about? Yeah, it should be better now, but okay. So I came across this, and the pricing model is quite what should say, expensive, like $15 per month. And given that I am from Pakistan, and here the dollar price is very high, so I definitely can't afford it. So I tried searching for some open source alternatives and then came across this thing called Athens Research, and there are Athens Research GitHub. Yeah, so their project is called Athens, and apparently they're trying to rebuild their ROM replica kind of, and they're totally open source. And then from there I came across this thing called ClojureFam, and it's an initiative, a learning program for learning Clojure and ClojureScript and DataScript, etc. And I've been meaning to learn functional programming for a while now, but because of some distractions, like other things caught my attention, like machine learning or deep learning or quantum computing, etc. And I got busy with that and accepted a semester project, etc. But still, it was on the back of my mind that I should learn functional programming, as I've heard quite a lot of good things about it. Like, it completely changes how one thinks about solving problems. Like, I've learned quite a few languages like C++, Java, Dart, Go, Julia, etc., among others like JavaScript and C Sharp, etc. Like I've worked in a lot of different languages, but mainly all those languages are object oriented, and most of the time they're derived from C family or C like family. So I wanted to see how functional programming, especially Lisp like programming language, is different and how it would improve my understanding and workflow, etc. So I jumped on this opportunity to learn Clojure, and apparently they're very, like, they provide curated learning material, and their social accountability where like learning in public and peer-to-peer study, as well as they have good mentorship support. So now yesterday our team got started and I got assigned to a team, for example, and they have a tradition of naming the teams by Greek mythology. For example, Athens, and then there was um, team Phanes, and our team got assigned the name Team Prometheus. And Prometheus is known for his intelligence as a champion of humankind, and also seen as the author of human arts and sciences generally. So yeah, no pressure at all. So anyways, yeah, I thought about study streaming as a way to, you know, document this from myself, mainly for my future self as well as those who are starting new. So we'll start from the very basics, like setting up the, I'll mainly program in VS Code, so I'll set up Canva. I might later on try Emacs or Dominex or IntelliJ, but for now I'm thinking about setting up Canva, and then we'll try and go through this and try and read Clojure from the ground up. So first let me bring up Visual Studio Code and we'll try to set up Canva. Yeah, where's the extensions and Canva. Canva, Clojure, and ClojureScript interactive programming. Yeah, let's install that, and then we'll try to learn a little bit about Clojure from the ground up. Apparently we should do a couple of our first 4 chapters, and then we'll switch on to Clojure for the brave and true. Also, if possible, we'll try to solve some for Clojure problem, but I think in first few days I won't be able to, but let's see. Yeah, Clojure from the ground up. So I think their first chapter might be, let's start from the welcome and then basic types. Clojure, later Team Prometheus. Yeah. Clojure from the ground up. This guide aims to introduce newcomers and feel alive to the beauty of functional programming, starting with similar brain for computer based guide for science to apparently it's written by a woman, I guess. Yeah, as we often assume that avoid the but I'm afraid I would call okay. Why I'm reading this? Why Clojure? This one is learning Clojure, which is a modern dialect of a very old family of computer called Lisp. Yeah, I've been interested in learning Lisp for a while now. It's been on my wish list for ages, it seems like. So we're going to explore the nature of syntax and language so till now what I know about Clojure is just that it's a Lisp like language, Lisp inspired language, or I guess I should say Lisp language that's set up in the JVM environment. Okay, so personally don't really like Java that much because of its verbose syntax, and strangely enough I like C# better than Java. But let's see how it goes. It is ROM Research for JavaScript. Alright, let's remember the 15-step system. So it's fast, it's type safe probably, yeah. Concise, yeah, I love concise programming, especially the one-liners in Python. I do really love those, requiring very little code to express complex expressions. Yeah. REPL is always good. And dynamic type system, so it's type safe as well as dynamic. Ideal for beginners to experiment with and well suited for manipulating complex data structures. You can understand the library and protocol. Only there are some drawbacks. Okay, it's a compiled language, type safe language, dynamic type system, much slower to start. Okay. Not suitable for interactive use case. Not well suited for high performance numeric operations. Recently I've been coding a lot in Julia and I really like it. For example, there was a project that the same code I wrote in Python and in Julia. First I wrote it in Python and then I tried running it, and it took like 6 hours or more, and still it was running. Like, it wasn't complete, it hasn't completed yet. But then I tried Julia, switched to Julia, and the same algorithm, it ran in like 4 seconds or 3 seconds, something like that. So yeah, it's really fast, and I really enjoy learning Julia or programming in Julia. I'm by no means any expert or I don't really know the peculiarities or nuances of coding in Julia. Just basic structure, basic. It's almost like Python code, same to same in Julia, but still it was way faster, and I really like that. So it's not for high performance numeric compression. Jump through hoops, I don't like jumping through hoops. Performance comparable with Java. Okay, but Java's performance isn't that mind-blowing either, right? I mean, C++ is faster than Java, and I guess Rust is faster than Java probably. Yeah, Rust, I've been planning on learning Rust as well. Should I go with 1.7 or any? Yeah, let's go with the LTS release. Okay. Is it going to start? Okay, I guess I have installer. Yeah. Yep, of course I reviewed it. Of course I reviewed it. Anyways. Google sign in. Well, let's sign in from the old account. Really? So how am I supposed to download? Why do they require signing in? I don't get it. Why do they require signing in? I can try scoop install JDK, scoop installer Java, install JDK scoop and say hello world. So yeah, let's try scoop. group search JDK. Why is it? Yeah. So we can install OpenJDK or I guess Oracle JDK. One is 14 and then I guess this is the LTS version. Yeah, let's install Java bucket to install Oracle JDK. Oracle JDK. Hopefully, anyways. Oh, do you really need learning? Okay, I thought there will be instructions for I guess we'll have to add in the bucket first. Scoop bucket add Java, and then should install OpenJDK or Oracle JDK. What the hell is the Java bucket was added successfully. Installing Oracle JDK 14. I thought it would install the LTS version. Anyways, linen gen. I don't know how to pronounce that. For automating Clojure projects without setting your hair on fire. Use Clojure in project automation and declarative configuring. Okay, this seems like Emacs script. I think I haven't used Emacs. Just I was trying to set up org.dom, but wasn't able to on Windows especially. Download the lin script on Windows lin.byte. Place it on the path where shell can find it. Set it to be executable and download the file package. In this we can save it as line byte or files. Let's see. Yeah. First, oh, okay. So this will install it, and then you can start with the primary command line basics. Okay. Okay. So it is kind of like a npx kind of thing for Clojure. CV workspace. Here we will try to create a workspace, a project for Clojure. I don't know why it's taking so much time, even though my network speed is quite good at this time. Hopefully it will complete without any errors. So So use your home directory scratch if you see command from the social point with the other line. You can install it. Okay. I'm supposed to put it on a path. Should I put it on my, well, let's create some path here and let's add that in the system variable. Environment, edit the system variable, environment path, edit new. Okay. Hopefully it will work. We'll see after this gets installed. Oh no. Okay. Team Friends, yeah, that's me. Friends and Prometheus, yeah. Team Friends was previous team and this is Team Prometheus. Creative skill and technology. Yeah. Inshallah we'll do better. Inshallah. A champion of humankind. Of course. So 80% still going strong. If you don't know about the Athens or Athens Research, you should check it out. It's kind of like a ROM Research database, quite similar to LogSec. LogSec is, I guess, more further along the path than Athens because they have a finished product and they are working relatively well and they have more features, but they're not fully open sourced yet, so I don't know how to feel about that. But I'm excited to learn about Clojure and at the end hopefully contribute to the Athens database. That's my main goal. If you take a look at the ClojureFam, there the learners complete the program when they merge code into Athens database. So I've been meaning to contribute to open source for a while now, and I think this will be a great opportunity for me to do so. This is Athens database. If something has been done, hopefully, why you should learn Clojure. Yeah, you should read that. Why you should learn Clojure. Yeah, I guess I've got a lot to learn here and a lot of different idioms and concepts and abstract ideas, but let's see how it goes. So I got installed cd workspace. What was the command? Lein new scratch, lein new scratch. The term len is not recognized in the name of command line from the program. Okay. cd bin clear, and here it's main.bat. You can try running, could not be found. What? Let's try lean self install. Okay, lean.bat self install. Yeah. Move the Windows, place it on the path where shell can find it. set it to executable, run it, and it will download the self-installed package. Okay, it's downloading the self-installed package. I guess it's done, but do I have, is it working now? No, I'll have to line.bat new scratch. Why? Oh, let's set it around. Line.bat new scratch. Let me see if this will. Yeah, it's working now. Clear cd workspace. So yeah, I had to restart the shell too, so it could get the updated path environment variables, or at least I think that's what fixed the problem. Len.bat new scratch. Generating project called scratch based on the default template. The default template is intended for library project, not applications. Okay, so we've got our project setup. Cd scratch ls. Okay, there's quite a lot of things there, like docs, resources, ls, doc. Okay, ls. Okay, lane. Okay, lane REPL. Something is happening. The structure of programs. When you type lane REPL at the terminal, you'll see something like this. Server started on port this. Okay, a server will start shortly. And your doc, source, javadoc, exit. Quit. This is an interactive Clojure called REPL. Yep, REPL stands for read, evaluate, print, loop. If you come from Python or Julia or MATLAB, etc., then you probably know what REPL is, and it's a very good feature to quickly learn about the language as well as test new features or ideas if you think that something should work. So REPL has started at localhost 59741. So let's go localhost 59741. 59741. Okay, do I have to type in REPL? Let's see what they say. So the simple function type null and type enter. User, is it started here? Okay. Let's write out the 127.0.0.1 59471. Is it working? Nope. So I have to type in here. Let's copy this thing, and nope. REPL started in port 59741 on host localhost. So now it started, or one thing is, yeah, this is the REPL and it's hosted from there. I guess I can't access it from the browser as I was expecting from things like JavaScript or other server based. Probably my bad. I was in Prometheus. So if I type null and hit enter, you get null. Let's do this. If you can't see what I'm typing, hopefully it will be clear. No, oh, I forgot that I'm not in the terminal or bash. Nil is the most basic value in Clojure. It represents emptiness, nothing, not a thing, the absence of information. Got it. So it's kind of like null, or in Julia there's nothing. Yeah, nothing, or missing. No, not missing in nothing. And C++ there's null, and in Python I guess none data type is close to it. So nil is the most basic value in Clojure. We can emptiness, nothing. Okay, true is true, false is false, as expected. Trues are pair of values called booleans. Yep, they mean exactly what you think, whether statements true or false. Okay, nil and 0. This is the number here represents its numeric friends at 1. Okay. Okay, so there's exponential input as well as fractional. Let's try fractional. 1/3. It's not evaluated. Okay, I thought it would evaluate it. What's 1/3? Okay, nothing. And what about 3/1? 3/1 is 3. 3/2. Okay, I guess it will evaluate it. It will reduce it to its base form. Yeah, strings, but I want to see if true is equal to 1. Yeah, and false is equal to 0. Nope. I don't know what's the syntax for equal here. Equal to, is it the same, or I guess we'll see later on. So what this is the number 0, it's numeric friends, or this either simple, it's a string, and a string gets printed. Nil, true, 0, and either are different types of values, the nouns of programming. Okay, yeah, just as one could say house in English, we can write a program like hello world and evaluates itself the string hello world. But most sentences aren't just about starting the existence of a thing, they involve action. We need verbs, of course. So there's a thing, I guess it's called increment. This is a word called inc, short for increment. Specifically, inc is a symbol which points to a verb. Okay, yeah, this is the verb, something that performs some action. So in this case, increment, it increments something. Increment, for example, by probably 1. I don't know if we can specify how much to increment by, but most probably it will be, by default it will be 1, most probably. Yeah, there's a key distinction here, that a signifier, a reference, a label is not the same as the signified, the referent, and the concept itself. If you write the word run on paper, the ink means nothing by itself, it's just a symbol, but in the mind of reader that symbol takes on meaning, the idea of running. Okay, unlike the number 0 or the string high, symbols are references to other values. Yeah, when Clojure evaluates a symbol, it looks up that symbol's meaning. Look up ink and you get Clojure ink clojure.core. There's core library, I guess, and then there's a function in it called ink. Probably, we'll see. Can we refer to the symbol itself without looking up its meaning? Yes, the single quote escapes a sentence in programming language. So ink, yeah, if we type ink, then it gives us the whole object. For example, object, and this is from Clojure core and ink, Clojure core ink. There's a string representation, or I don't know. But if we type single quote ink, then it gives us the symbol itself. So this is the symbol, and this is the meaning according to them. According to this definition, this is the symbol and this is the meaning. Okay, yes, the single quote escapes a sentence in what we call sentences, expressions, or statements. Yeah, this is a simple expression or statement. 3 plus 2 is a simple express. Oh, there's no plus, or I guess no, there is plus. This is 3. Okay, and this is the meaning of plus, and this is 2, but they aren't evaluated. In case E2, nope. Okay, we'll see how it goes later on. Yes, the single quote is case or improve. A quote says, rather than evaluating this expression's text, simply return the text itself unchanged. Okay, yeah. A single quote. Quote a symbol, get a symbol. Quote a number, get a number. Quote anything and get it back exactly as it came in. Quote a number 1 2 3, get 1 2 3. Ooh, ooh. 1 2 3, 1 2 3. But 1 is the same as quote 1, right? But yeah, for literals I guess it's the same thing, but for symbols, variables, it's different. A new kind of value surrounded by parentheses, the list. Okay, this is the list. In Python, or yeah, mostly in Python, we specify list like 1 2 and 3, but in this case in Julia, I guess MATLAB, the space is also fine, but in, yeah, let's try it without the single quote and let's see what we get. Execution error. Okay, class java.long cannot be cast to class clojure.long. Oh, that's a little cryptic. Anyways, so this is a list. List originally stood for list processing, so it's probably the major focus of lists would be processing lists efficiently, and most probably the functional programming paradigm or the Lisp paradigm or the Lisp coding style will focus more on how to convert the data into lists and process that efficiently, I guess. And lists are still at the core of the language. In fact, they form the most basic way to compose expressions or sentences. A list is a single expression which has multiple parts. For instance, the list contains 3 elements, the number 1, 2, and 3. List can contain anything, numbers, strings, even other lists. Okay, that's good. So we can contain, yeah, I was wondering about that. 1 and do we have to let me see, is this optional? Yeah, I guess we can instead of single quote, I mistakenly put back quote there, and apparently it's behaving the same, so I don't know it's single quote or back quote. Okay, so we have this, and then we have a string, and then we have nil, and it behaves fine, so that's good. Okay, for instance, 3 elements, the number there can contain anything. A list containing 2 elements, and family list, the list contain 2 elements, the number 1 less than 2 elements 3. Okay, a list contains 2 elements, the number 1 and a second list. This is the number 1 and this is the second list. That list contains 2 elements, the number 2 and another list, and that list contains 3 elements, the number 3 and an empty list. Okay, you could think of this structure as a tree, yeah, which is provocative idea because languages are like trees too. Sentences are comprised of clauses which can be nested, and each clause may have subjects modified by adjectives and verbs modified by adverbs and so on. Lindsay, my best friend, took the dog which we found together at the pond on 4th Street for a walk with her mother Michelle. Okay, this is verb. Lindsay took. Lindsay took was Lindsay, my best friend, the dog which we found together where at the pond on 4th Street for a walk with her mother Michelle. Well, let's try. So this is kind of like a tree. This is these two are nested in the took, and my best friend is nested in the Lindsay and the dog. Here the two main branches are which we found and for a walk, and at the pond and on 4th are the parent-child relationship. They have the parent-child relationship. Okay, so Why is it broadcasting to poor connection? Why is it poor? Okay, well, let's try something simpler, something we know how to talk about. Increment the number 0 as a tree. Increment the number 0. So we have a simple for incrementing, and we know how to write the number 0. Let's combine them in a list. Okay, yeah, it would simply return the list without incrementing, because we're not really evaluating the expression, we're just printing it, I guess. So basic sentence, remember, since we're talking about the tree, the text, the expression by itself. Absent interpretation, if we remove the singular, Clojure will interpret the expression. Okay, so if I want to increment the number 0, okay, that's how it's going to be. So we'll have to deal with a lot of lists and list manipulation, etc. Okay, yeah, I can see why it's different from other languages. For example, in C++, I'll have the inc C++, except there's plus operator, or if there's a which contains 0, then I can this, etc. So different increment things, but those, yeah, it's different syntax, completely different, I'd say. Increment 0, yeah, it returns 1. Incrementing 0 yields 1, and if we wanted to increment that value, increment the number 0, yep, it would be increment and then another list, and yeah, this will be 2. And if we want to increment again, we'll have to include, but isn't that more verbose than, for example, a plus or equal to 3? Okay, we'll see. A sentence with the left, it starts with a verb. Okay, it will start with a verb, something to perform, some action to be performed on some data thing. It starts with a followed by 0 or more objects for the verb to act on. Each part of the list can itself be another list, in which case the nested list is evaluated first, just like a nested clause in a sentence when we type inc 0. Clojure first look up the meanings for the symbol in the quote. Okay, this is the meaning. Performs this action, perform this action on this object, then evaluates the innermost list. For example, it will evaluate this first, and then it will evaluate this, which becomes the number 1. Finally, it evaluates the outer list. First it evaluates this, it becomes 1, and then it will evaluate the outer list, which will increment the inner list, which is 1, and resulting in 2. Every list starts with a verb, part of list or value from left to right, and list or value to before outer. So wow, so this is postfix notation, I guess. Yeah, post, no, this prefix notation. Prefix, where's okay, let's try to add what, add another list which contains 3 to. Will this work? Nope. Okay, let's try to add. Okay, add takes 2 arguments, first and second. Yep, that's how it goes. Let's try to add and subtract from 3 and 2 and add 1 to it. So 3 minus 2 is 1, and then 1, it's 2. Okay, so this will evaluate like this, 3 minus 2, which is 1, and then we add 1 plus the result of this, which is 1, that is 2. Okay, yeah, plus 3 plus 4. Okay, it evaluated this. So if we take a look at this, what is happening here? Let me quickly copy and paste it, and okay, I don't get yeah, probably we can add multiple things as well. Example 1 2 3. Yeah, so here it is evaluating innermost loop first, and probably this one because it comes first and have at the same level as this one. So 5 minus 2, here 5 minus 2 is 3, and then it will evaluate this. 3 plus 4 is 7, and now it will add 1 plus 3 plus 7, and that's 11. Okay, the intergram of left the structure for every expression in the language. We transform expressions by substituting meaning for symbols and obtain some results. This is the core of the lambda calculus, and it is theoretical for almost all computer languages. Yeah. Ruby, JavaScript, C, Haskell, all languages expect the test in different ways, but internally all construct a tree of expressions. Yep. Yeah. During my master's subject in compiler construction, we came across these trees that compilers construct in order to evaluate expression. So yeah, basically they do that, but at a lower level. So here I guess, so there when we write 2 plus 3 in C++, let's say, so it will reconstruct this for us in the compilation step, right? But here we are explicitly stating that there it's doing this for us, but here we are explicitly doing it ourselves. Okay, so why is it not streaming very well? Yeah, anyways, excellent. So review, we started by learning a few basic nouns, numbers like 5, strings like cat, and symbols like ink and plus. We saw how quoting makes the difference between an expression itself and the thing it evaluates to. Okay, we discovered symbols as names for other values, just like how words represent concepts, and finally we combined lists to make trees and use those trees to represent a program. With this in time to learning how to represent more complex values and transform them in different ways. Yeah. So we're done with the welcome. Yeah, welcome section. Now it's chapter 1. Let me see if I can solve any foreclosure problems at this stage. Intro to strings. Yep, I guess we can solve this. Difficulties very good. Clojure strings is Java strings. This means that you can use any of the Java string methods and Clojure string. Okay. Dash to uppercase hello world. Clojure string the Java strings. Intro to string. This means that you can use any of the Java string methods on Clojure strings. Okay, something is equal to dash to uppercase hello world. I guess there we require some variable. I don't know, it's very, that's strange. Let's try. They should give a little more instructions on what they want us, what they want from us. Why is the network connection very poor? Can you guys hear me well? I don't know if you can. Anyways, so we're trying to uppercase. What to uppercase? Hello world. And we'll resolve symbol A in this context. So yeah. Do we have to add something like string or capital S? String A. But I don't know what they're expecting from us. I mean, let's come with either a function or a quoted form. Wait a minute. I guess here, yeah, now I get it. So there's equal to, and we have to do hello world, which is in turn equal to dot to uppercase hello world. I guess, yeah. Code which fills the hello world. Let's run it. We solved the problem. Wow. Let's register. Username, admin, password. I'll do that later. Yeah, we solved the first problem. Intro to lists. List can be constructed with either function or a quoted form. Yep. Okay, there's a. Now what's this? I guess let's. I don't know if we should carry on with this or. Okay, yeah. I guess we'll try to do this in the next session. For now, let's try to figure out what will go here. So is equal to what is equal to list. List is a function, so probably it will. These are, I guess, symbols. Yeah. Which is equal to A, B, and C. Yep, we figured it out. Code which fills in the blank. Control C, Control V, run. Yep. So here what they are trying to say is that you can create lists in two ways, either using this quote, backquote or quotation, backquote and a single quote, for example single quote, and then this is a symbol instead of there's not A but there's A. This is a symbol. We haven't learned how they represent symbol or what they really mean by symbol yet, but I'm just guessing that this is a symbol, not a literal A. Anyways, this is A, B, and C. This will give us a list. For example, like copy, paste. Did not copy. Anyways, so this will give us a list ABC. In the same way, this will give us a list ABC. So there are multiple ways to create lists. Okay, and then we can conjugate probably one operating list. The conj function will return a new list with the one or more items added to the front. Okay, this will append or add the items to the front. Note that there are two test cases, but we expect to supply only one or cause all tests to pass. Okay, is equal to conj. Yeah, here we can simply say that one will be added to the front, so the new list would be 1, 2, 3, and 4. Most probably, yeah, here. Okay, in the next case, let's break down this case. So here I'll type this like this. So first it will conjugate. Okay, I should have put in the conj conjugate of 3 and 4 and 2. So this will be 2 3 4, right? And then when we conjugate with 1 as well, so this will be 1 2 3 4. So this is like reverse. Okay. So conjugate function is being applied on everything recursively, so we can do this. We should have been able to do this, right? Nope. I guess lists are required first argument, then we can do this. So 2, first it will get 2 and then 1 and then 0, so 0 1 2. That makes sense. Okay, intro to vectors. Vectors can be constructed several ways. You can compare them with lists, note the brackets, not angle blanks with dash or part of the test case. Yeah, vectors can several. These are all different ways to construct vectors. This is equal to, here I'll have to put, I guess, A, B, C, yep, and they are equal to A, B, C, and so we don't need backwards for those, but we need backwards for left, backwards or single quotes. Yep, and they are same. So what's the difference between vector and list? There's also vec form, which converts a list into a vector, and then there's vector which takes single arguments and converts them into a vector. Okay, here we simply add A, B, C and run it. Yeah, we're figuring things out without learning it yet, which is a good thing, I think. Boolean logic, then there's symbols. What are symbols? So I guess I've been calling them symbols, but they really are keywords. Yeah, so I've been calling this semicolon A a symbol, but it's not a symbol, it's a keyword according to Lisp language linga. Okay, then there's lifts, we'll learn about this, and then there's a vector. Okay, and then there are sets. So I guess in the next section, in the next session, we'll try to go over these types, and then we will complete these 4 Clojure challenges as well. Till then, yeah. Yeah, I guess for now it's goodbye, and I don't know when I'll stream next. Most probably another session today as well, but no promises. Still, I'll post the link on Twitter or update on the Twitter feed if I decide to stream today as well. Otherwise, I'll most probably stream tomorrow with the next session or with the next chapter and next exercises. Let's see how it goes. Okay.